Hi, my name is Tor Davenport, and welcome to Tor's Tech Talk. All right, so in this video, we're going to go ahead and look at some port forwarding. All right, taking a look at our lab here, we have a small setup with 3 routers, right? So I have a Windows machine here, connecting to a switch here. This is just passing traffic on a single VLAN. It's all layer 2, right? This is our first hop. This is our first router, right? We have a inside LAN and an outside WAN. But since we're daisy chaining 3 routers, we're going to have triple NAT, and I need to port forward from this machine to this machine so that this machine can connect to this machine on port 80. If we go ahead and open up this machine right here, we can go ahead and try to ping 172.16.0.20 just to show that that's not going to work, right? TTL expired in transit. The way that I have it set up, it might just be sending and then that TTL expires and drops the traffic instead of the packet just dropping. Might have something to do with the way I set this up, but in effect, it does work. The ping from into the LAN obviously does not work, right? So this Comcast modem right here is going to be our first hop. And so its public IP is 22222222. So let's go ahead and ping that. So we can actually ping that, but we should not be able to ping the 172.16.10.1 behind it. Let's go ahead and try that. And we do not get a ping there either. So everything is working correctly. This is our small LAN. This is our first hop, which is supposedly an MX250. This is our second hop, which is going to be a Cradlepoint router. And this is going to be Comcast coax. This is all a hypothetical situation just to test out support forwarding. So you can go ahead and see that you can, in fact, set up port forwarding. And we'll look at the configs as well. But just to test it, I've got this machine here. And let's go ahead and open up this machine here. We're going to use a tool called Netcat. And with Netcat, we're going to be listening on this machine, right? Remember, that is our far side machine. So if we go like this, you can see it's this Windows machine here. We're going to do nc.exe, right? And what I've done is I've just downloaded this and unzipped it onto my desktop. Then I can navigate to that folder and access the executable within. You can see that 64-bit and 32-bit version is in there. So you don't need to install this. You just extract it. And if your antivirus doesn't flag it and remove it, it should work just fine. These are lab computers, obviously no antivirus there. All right, so we're going to do -LP for listening and specifying a port. So we're going to listen on port 80. Oh, hang on 1 second here. Let's see what we did. So maybe I didn't do this right. Yeah, I think it's just the dot and the backslash is missing. So -LP 80. All right. So you get this little blinker here. This is just waiting for a signal. Now port 80 is open on this machine, and we should be able to connect to it from the far side, right? But we cannot reach its internal address, obviously. So what we need to do is use port forwarding, which we've already configured to forward that port along each hop in the path. And then we can actually just connect to the forwarded port on the public IP address outside of that network. So let's go ahead and ping. I already pinged that. We can see that it actually does work. So we're just going to go ahead and connect to it. So I'm going to do netcat-exe. And in this case, I'm just going to put the IP and space, and then the port number. So boom. Now we should have a connection between the two machines. Netcat is a great tool for doing this sort of thing and just testing, uh, using it in the lab, also for ethical hacking and all different sort of amazing things. It is the Swiss Army knife of networking. So download it and learn it if you can. So we're going to go ahead and say test. And as you can see, I can kind of use this almost like a chat window, chatting here. So we're sending communications back and forth. This is a very basic level of what we're doing, but it's enough to really show us that the port forwarding does work. All right, I don't need a server. I don't need to stand up a web server or do all this stuff. I could just need Netcat, open up the port, and then I can test. So we're going to do something else for fun. We're going to try to render a basic web page. So what we'll do is go ahead and open up Chrome on this Windows machine here. 22222222, and actually I want to specify HTTP. So we're hitting port 80. All right, now you can see that it is connecting. I'll get the banner here, the HTTP banner grab, which is another use that this tool is good for. And then what I'm going to do is just type in some very basic HTML, right? I'm going to put a body, and then we're just going to do an H1 that says this is a fake page. And then we're going to do another body, close our tags, body close, and HTML close. Right. So real basic. This is a fake page. I can send that HTML to the web browser and it renders just fine. Now, interestingly enough, if I were to try to add anything else to this, it's going to get a little weird. It's not super dynamic, but it's pretty cool if you want to just serve up a fake page using Netcat. You probably could do that pretty easily. So we'll do an H2. This is another one. That's what we'll say. And we'll send that. And it does render and pop up. This is pretty cool. All right, so we know that works. That's great. Let's go ahead and maybe we can close this out. And the last thing I'm going to try to do, and this might take a little finesse, but we will now try to send a file. So in here, I'm going to say we're going to receive a file. We're going to name it. Basically what I'm doing, anything that comes through this port is going to be redirected to this new file called test.txt. Go ahead and hit enter. So now we're listening, and I'm going to attempt to push a text file without actually typing anything, just push a text file through. So bear with me just one sec while I get that set up. So to push this file, we should be able to now okay, so yep, that's what we need to do then, right? So might not work, but um, that's what we get for trying to do stuff live. So we'll give it a shot. All right, we'll do netcat dash w3 and then 22222222 or 80. We're gonna push this file hobbit.txt. Did not work because that operator is not apparently allowed. It's not good. So I might have to play with that one a little more. But what I could do, we're still listening here. So what I could do is actually just go ahead and wait a minute. I know what it was. Not cat. Okay, nope, that's not working for us. All right, let's give it a sec. I'm not sure if it's gonna. Oh, it did send the file. It looks like it closed the session, which is typical. It will close the session when it's done. Just go ahead and do a little diff. Sorry for the roughness on that one. Wasn't really prepared. I just thought that'd be pretty cool to show. So if we do cat hobbit.text, nothing is in that, which means if we do cat test.text, nothing is there. So in this case, we're going to say, this is a cool Hobbit. We're going to append that to Hobbit.text just in case there is anything there. And we're going to just do this again. Now that I know there's something in that file, we're going to go ahead and remove the test.text. And we're just going to go ahead and listen on that port and redirect there again. And then we're going to go ahead and push the file. Give it a minute. You could do this with more than text. You could push an entire file. There's a lot you could do. Push an exploit, perhaps, and it will work, right? You can do a chat server. Yeah, apparently it didn't send that. So there is something I'm doing wrong here, but in the end, it's all good. Still showed you what I wanted to show you with the port forwarding. We'll circle back on sending files with Netcat in a different video. Let's take a look at the config here. So start on this router. All right, go ahead and do show run. And we'll take a look at the pertinent config. So gig 00, that's our gateway for the LAN here. And then gig 01, gig 02 is going to be our WAN IP, which is actually getting a private address from the next router above, right? And then this is, so that's fine. We've got NAT outside, we've got NAT inside. I'm going to go ahead and see, we've got the source static NAT, that's our port forwarding, but we've got a route, so we're going to do a default route pointing at Cradlepoint, and then we're going to do IP access list extended NAT. This is going to match on this whole subnet, the LAN /24, and then we're going to use that here to say IP NAT inside source list NAT. It's going to be interface gig 02 overload, and then we're going to go ahead and that'll give us our path. So we'll do show NAT translations. And I needed IP there. Show IP NAT. So if I actually just ping the gateway of that Comcast, it actually isn't gonna work. It's probably not set up that way, just because this is a quick and dirty lab, right? But now you can see those translations occurring here. DNS trying to resolve port 53. So that's working. And then those will expire. So, but let's clear them. Do clear IP NAT translations all. Now we're going to do that port forwarding test again. And so let's do a basic one where we don't worry about the file. You know, we just connect to it. Because obviously my file sending skills are not on par. But now we can take a look at the network. We cleared those translations. So now we're only going to see translations relating to what we're doing here. So you can see let's just go ahead and close these out. Leave that open so it's active connection. Goodness, sorry about that. All right, so now looking over here, 10, 10, 10, 2, right? That's going to be our outside global. And then inside local is going to be 172.16.02, and 192.168.02 is that inside global. So basically what that means is inside local is your machine, or your inside global would be the public IP of that router, or the outside IP of that router, just that. And then here we are doing some port forwarding here. So that's good. It's also trying to resolve DNS because I have that configured, but obviously Lab has no real internet access. But it's not enough, so that's one router config, right? Remember, we've got a triple NAT scenario here, which obviously is not ideal. Let's do a show run. All right, 172 NAT outside, NAT inside, 10.1. So if you look at these, you can see 10.1's the inside gateway for this transit network. It's called a transit network because it only exists between these two interfaces on this one single link. It's for transit. It could be a /30, but you know, in this case, it's not. So you can see here the natting, same deal. We're matching specifically on what we want for to be natted. We're saying it's the inside. It's going to be the sourceless NAT, and it's going to overload interface gate 1, right, the outside interface. And then we're going to overload. That gives us PAT, port address translation. Check it out if you have not already. And then so for our static NAT, now we're just doing the same thing, right? We have to do the static NAT again. We're going to use this IP here to 10.2, right? Because the first one we forwarded from here to the 10.2, right? So now we're going to forward from here, from 10.2 up to the 172.16.10.2, right? So here to here, connecting these two, here to here, port 80, here to here, port 80, from here to here, and then again here up to here, port 80, right? So this computer can't reach any of this infrastructure. It gets stopped right at the coax firewall like it should. However, with port forwarding, port 80 on this address is open. It'll forward that connection here, down to here, down to here. So that connection can be established. It's pretty cool stuff. And if you're curious, you want to see it, which you know you do, we're just going to take another look at it. And really, the port forward in this case is a single line. It's pretty straightforward. You do need to implement the NAT as well. There's the IPs, and here's the natting, and then there's the access list for the NAT. So that's it in a nutshell. You can do some really cool stuff if you have your own lab. And this just happens to be a scenario that I actually needed to test for a project. And I was able, while I don't have those actual devices, I was able to do a similar test in the lab. So thank you so much for viewing. Have a great day.